Good morning students. Today is the second day of linear inequations. Today there are two concepts. We discuss a upon b. If a upon b is less than 0 and a greater than 0, then b is always less than 0. Second concept, if a upon b is greater than 0 and a is less than 0, then b is less than 0. For example, this is a, this is b. Now a upon b is less than 0 and a is greater than 0. We know 1 is greater than 0. Then b is always less than 0. What is b? X minus 2 is less than 0. So x less than 2. Now the value of x is less than 2. Less than 2 means 2, 1, 0 up to minus infinity. So minus infinity to 2. That's it. Again in this question, this is a, this is b. Now a upon b is greater than 0. Okay. A is less than 0. I know minus 1 is less than 0. Okay. Second condition. Then b is less than 0. Now what is b? X plus 2 less than 0. X less than minus 2. Less than means minus 1, minus 2, minus 3. Less than means minus 2, minus 3, minus 4 up to minus infinity. So minus infinity to minus 2. The next concept is a upon b form. Now this is a, this is b. This is a upon b form. A upon b greater than 0, a upon b less than 0. Now first of all we will find the critical points. Critical points. Critical points means if x minus 3 equals to 0, x equals to 3. If x minus 5 equals to 0, x equals to 5. So there are two values, 3, 5. Always put the plus sign in this area, minus sign in this area, and plus sign in this area. The whole line divided into 3 parts. 1, 2, 3. This one is of positive, this one is negative, this one is positive. Now we see the sign. The sign is greater than. Whenever the sign is greater than, we select the positive parts. Minus infinity to 3, union minus 5 to infinity. This is the answer. Similarly, in this question, the critical points are 2, 3. The sign is plus, minus, plus. But the sign, the given question, the sign is less than. If the sign is less than, we select the negative part. So the answer is 2, 3. So there are another two examples of a upon b form. So in this question you are not supposed to do the cross multiplication. So this is another rule of a upon b form. So x plus 3 upon x minus 2, shift this number to this side. Minus 2 less than or equals to 0. The rule is shift this sign to this side. This plus 2 becomes minus 2 and less than 0. Now take LCM. X minus 2, x plus 3 minus 2x plus 4 less than 0. X minus 2x minus x plus 7 upon x minus 2 less than 0. Another rule for a upon b form is there is a no negative sign with x. So x minus 7 upon x minus 2 less than 0. When we change the sign to another side, shift the sign to another side, x minus 7 upon x minus 2, the center sign changes. Though less than sign becomes greater than. So the critical points. Now this is a upon b form greater than 0. Now the critical points are 2, 7. So plus, minus, plus. But the sign is greater than, we select the positive parts. Minus infinity to union 7 to infinity. Okay. The next one, 6x upon 4x plus 1. Shift this half to this side. This becomes less than 0. Take LCM. 2 4x plus 1. Now this becomes 12x minus 4x plus 1 less than 0. So 12x minus 4x minus 1 upon 8x plus 2 less than 0. Now 8x minus 1 upon 8x plus 2 less than 0. Now another formula rule for the A upon B form is there is no number with x. So we take 8 as a common. X minus 1 upon 8, x plus 1 by 4 less than 0. So 8 cancel. X minus 1 upon 8, x plus 1 by 4 less than 0. So this is the exact A upon B form. Now we find the critical points. The critical points are minus 1 by 4, 1 by 8. So plus, minus, plus. Now the sign is less than. We select the negative part. So minus 1 by 4, 1 by 8. So this is another example of A upon B form. So in this question, 2x plus 4 upon x minus 1. Shift 5 from this side to this side. This becomes less than 0. Take LCM. X minus 1. 2x plus 4 minus 5x plus 5 greater than 0. Now 2x minus 5x minus 3x 4 plus 5 9 upon x minus 1 greater than 0. Now we know there is no number or negative sign with the x. So we take minus 3 common from numerator. We can say a. So x minus 3 upon x minus 1 greater than 0. But when we shift this sign to this side, the center sign changes. So x minus 3 upon x minus 1 becomes less than 0. Now we find the critical points. The critical points are 1, 3. But the sign is less than. So this plus, minus, plus. So we select negative part because the sign is less than. So the answer is 1, 2, 3. So this is the last example of A upon B form. So please listen it carefully. Now x minus 2 upon x plus 5. Shift 2 to this side. Minus 2 greater than 0. Take LCM. So x minus 2 minus 2x minus 10 greater than 0. X minus 2x minus x minus 2 minus 10 minus 12 upon x plus 5 greater than 0. Now take minus as common from numerator. So minus x plus 12 upon x plus 5 greater than 0. Now we shift this sign to another side. The center sign changes. Now we find the critical points. So minus 12, minus 5. So plus, minus, plus. The sign is less than. So we select the negative part. So minus 12 to minus 5. Minus 12 to minus 5. So we're done with the exercise 16.1 from the R.D. Sharma. Now we start with the exercise 2nd. Solve the system of linear equations. So how can we solve? So 3x minus 6 greater than 0. 3x greater than or equals to 6. X greater than or equals to 6 upon 3. X greater than or equals to 2. So the interval is 2 to infinity. So in this case, 4x less than or equals to 6 plus 10. 4x less than or equals to 16. X less than or equals to 4. So the answer is minus infinity to 4. So draw a number line. Infinity minus infinity. 0, 1, 2, 3, 4. The first is 2 to infinity. 2 to infinity. The next one is minus infinity to 4. Minus infinity to 4. So the common area is this. So the answer is 2, 2, 4. So this is a common area between the two linear inequations. Similarly, in second question, we take the LCM 8. So this becomes 10x plus 3x greater than 39 upon 8. 13x upon 8 greater than 39 upon 8. 13x greater than 39, x greater than 3. So the answer is 3 to infinity. Same, again we take the LCM 12. So the LCM is 12. So 2x minus 1 minus 4x minus 1 greater than 3x plus 1 upon 4. Now 2x minus 1 minus 4x plus 4 upon 12 less than 3x plus 1 upon 4. 2x minus 4x minus 2x minus 1 plus 4 plus 3 upon 12 less than 3x plus 1 upon 4. Now cross multiply. So minus 8x plus 12 less than 36x plus 12. So minus 8x minus 36x less than 12 minus 12. So minus 44x less than 0. So x, whenever the sign shifts to this side, center sign changes, x is greater than 0. So this becomes 0 to infinity. So on the number line, infinity minus infinity, 0, 1, 2, 3, 3 to infinity, 3 to infinity, then 0 to infinity, 0 to infinity. So the common region is 3 to infinity. So this is the final answer. I repeat, firstly we take the LCM. By taking LCM, we solve this linear inequation. The interval becomes 3 to infinity. Again, in this equation, second equation, we take the LCM, solve this equation. The interval becomes x greater than 0, 0 to infinity. Now, we plot both the intervals on a number line. So the common area is 3 to infinity. So this is the last example of this concept. So please listen it carefully. Now first of all we solve this equation. Now take the LCM 4. 2x minus 3 plus 24 greater than LCM 3, 6 plus 4x. Now 2x minus 3 plus 24 plus 21 upon 4 greater than 6 plus 4x upon 3. Cross multiply, so 6x plus 63 greater than or equals to 24 plus 16x. 6x minus 16x greater than 24 minus 63. So minus 10x greater than. So 13, 4, 9. So 5, 39. So 10x less than or equals to minus 39. Whenever we shift the negative sign to this side, the center sign changes. So x greater than or equals to minus 39 upon 10, x less than or equals to minus 3.9. So the interval is minus infinity to minus 3.9. Now we solve this equation. So first of all we solve the brackets. 2 multiplied by 2x, 4x plus 6 minus 10 less than 6x minus 12. Now 4x minus 4 less than 6x minus 12. Now 4x minus 6x less than minus 12 plus 4. Minus 2x less than minus 8. 2x greater than 8. X greater than 4. So the interval is 4 to infinity. So the answer of this equation is minus infinity to minus 3.9. The answer of this equation is 4 to infinity. Now we draw the number line minus infinity to infinity. So 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So minus infinity to minus 3.9. So prox, this is a class interval, and 4 to infinity. This is a representation of both the intervals on a number line. But we see that there is no common area. So we can say there is no bounded area between these two linear inequations. So there is no bounded area between these two linear inequations. So this is the end of this concept. Please see these concepts carefully. If you have any doubt, any sort of doubt, so please just text me anytime. Thank you.